Okay, in this video I'm going to show you how to rationalize the denominator with radical expressions, but this is a particular video in that both of the radicals in the denominator are what they call monomials. Okay, and there's a different technique when you have a binomial, so I'll save that for a different video, okay? So remember, these are for monomials only. Now, the purpose of rationalizing the denominator is to get the radical out of the denominator, right? It's just really an awkward way to write a quantity of some sort. So the rule, it's not really even a rule, but the technique is to multiply by whatever the radical is. Okay, so here, for example, we have like radical 6 in the denominator. Now, I can't change the quantity if I'm just simplifying, can I? I can't change this. I'm not solving for a variable or something. I'm just simply simplifying it. And to do that, I have to multiply by some kind of a number that won't change that quantity. And we all know that multiplying by 1 doesn't change the quantity of something, does it? So in this case, I'm going to multiply by radical 6 over radical 6. Now when I do that, look what happens in the denominator. Again, we know that when you multiply two radicals that are the same, radical 6 times radical 6 is radical 36. Okay? And we know that that's a perfect square. Let me just continue on down here. I'm just going to do just that problem only. And we know that the square root of 36 is just 6. Therefore, by that simple technique, I have rationalized the denominator. Now, some of the work that needs to be done is in the numerator, right? So I've got 2 radical 6, right? Have to multiply the like terms. So I'm going to get 2 radical 12. Okay, because you can multiply the radicands. Radical 12 I know has a perfect square in it, so I'm going to say 2 times radical 4 times radical 3. Now I know that radical 4 is a perfect square, so that's why I chose it. It becomes 2 times radical 3 over 6, or I get 4 over 6. Now 4 over 6 is actually reducible as well. All right, so 4 over 6 becomes 2 over 3. And that is a simplified version of that particular form here, of that particular expression, okay? And I've rationalized the denominator. Let's do the same thing over here. I've got 2 radical 3. Now, I could multiply it by 2 radical 3 as well using this technique over here, right? But I really don't need the 2. Really? I just need to get rid of the radical. So I'm going to multiply it by radical 3 over radical 3. Again, multiplying it by some kind of a 1. And I'm going to do the exact same thing. I'm going to rationalize the denominator. 2 radical 3 is really just 2 radical 9, which is just 2 times 3, which ends up being 6. Okay, again, the work needs to be done is really in the numerator. Now this is really just a distribution problem. Think of this as like radical 3 times 1 plus radical 3, where I just put the radical on this side rather than on this side, right? That's what it's over here, but I'm just going to rewrite it like this. So I'm going to get radical 3 times 1, which is radical 3, plus radical 3 times radical 3, which is radical 9 again. Now something to note, and this is what people like to do, they like to like cross out the radical 9s here as a 1, and you can't do that. The reason you can't do that is because 2 radical 9 is the denominator for both of the terms in the numerator, all right, because these are separated by an addition. So you can't do that. Think of this as just as a separate problem, okay? So this becomes radical 3 plus 3, right? That looks pretty simple. Again, I can't cross anything out here because it's the denominator for both terms, but I can do this 3 plus, I'm just going to move it around, radical 3. Now, you might ask, can I, like I did over here, can I reduce 2 over 6 to become 2 over 3? Become 1 over 3, rather? And I can. This is actually okay, right, as a final answer. But I could also do this. Remember I said that this is the denominator for both of those terms, so I could do that. Then plus radical 3 over radical 6. I could reduce this to 1 over 2 plus radical 3 over radical 6. Both this term, or both this expression and this expression, really are in simplified terms. These are what they call equivalent expressions. Either one of them is okay. I didn't really have to continue on over here. All right? Equivalent expressions is exactly what it means. These are equivalent, they're the same, okay? Just written in slightly different forms, but they're both just as simple as one another. Okay, hope that was helpful.